So right from the steam engine to vacuum tube computers to Python, it's all basically levels of abstraction on top of each other, how to automate the things around us. So essentially, if you are able to tell the machine and it is able to generate a program to do what you tell it to, and that's going to be the next stage in that sort of progression.
Hey folks, welcome to First Cheque Portfolio Shots. My name is Tejas, and this is a series where we speak to founders of our portfolio companies so that you get to know their team, understand what they're building, and the problem they're trying to solve. If you like the content that we've been putting out, do like, share, and subscribe so that we can reach more founders and startup enthusiasts like you. Today's very special guest is Sibesh, co-founder and CEO of Maya. They're building a powerful general purpose robotic assistant, a machine that can think, learn, and program itself to complete a variety of tasks as well as a human can. I had a really interesting conversation with Sibesh, and it was really great to learn about their culture and their plans for the future. Stick around till the end of the episode to learn more.
Hi, Sibesh. Oh, it's great to have you here. How are you doing today?
Hey man, yeah, I'm good. I'm good. I'm good. What's up?
Awesome. Awesome. So, Sibesh, this is the Portfolio Shots, and let's get started. So, my first question to you is, what problem are you trying to solve? What problem is Maya trying to solve? Can you tell us about that?
Right. So the bird's eye view of what we are essentially doing is our mission is to build machines which can sort of program themselves to do any task. So um, and just like humans think in terms of instructions, machines think in terms of programs. And so if you can teach machines how to program, create their own software, automate things based on what you tell them to do, it's sort of like teaching them how to think. And so that's the sort of big level mission that we're working on. And how that translates to actual useful things is that we're essentially building technologies which let you reduce the time to automate any task, and that may be something like a simple web navigation task to something really complicated like a industrial IoT automation. We're reducing that time from hours or days to minutes, right? So essentially, we're publishing research, we're making products and making technologies which essentially which aim to create the sort of forcing function towards uh, helping machines program themselves. So yeah, so that's the problem we are solving. Uh, the historical context of this problem is that essentially all of technological development or industrialization has been figuring out easier ways to automate, right? So right from the steam engine to the vacuum tube computers to Python, it's all basically levels of abstraction on top of each other, how to automate the things around us. So we think this is a natural progression in that uh, essentially if you are able to tell the machine and it is able to generate a program to do what you tell it to, and that's going to be the next stage in that sort of progression. So yeah.
That's amazing. And how are you solving this problem? What is the solution?
So essentially there are two parts of the problem. One is like the actual like research academic part, which is these technologies don't exist yet, right? So there's no one who's actually built these yet. That there's no GitHub repo to use. You search on Google for it. There is nothing which exists. The first thing is to sort of figuring out ways in which you can teach machines how to program, and that's a non-trivial problem. One of the biggest contributions that we have to the field is uh, uh, we figured out a new benchmark of how to measure how good machines are at programming themselves. So we published a few papers on how that is done. So that's the sort of research and academic part, and then just the academic part sort of won't sustain you for the long term. So to sustain all our research and development, we built a product to take these things to the market, which is essentially a low-code tool which allows you to build automations and run them very easily across different platforms, so Windows, Linux, Mac, cloud, etc. You can automate anything, basically anything you can think of, you can automate using our low-code tool, right from like navigating the web, making internal tools, switching APIs together, automating your email, automating spreadsheets, anything basically. So yeah, so it's a big growing market. So the market that we operate in is sort of the RPA market. It's a very fast sort of growing market. So uh, if we can reduce the time to make any custom automation from hours or days to minutes, then that's going to be the sort of the biggest contribution we could make. Yeah.
Really nice, really awesome. So, my next question is, what has your progress been so far?
Right. So we're currently in closed beta. We're going to launch in the next few weeks. And over this time, we sort of try to work with hundreds of users to figure out the right use cases uh, where we could reduce the automation time. So like very narrow, uh, uh, both narrow and specific use cases where to experiment with our go-to-market for how we could commercialize the technology that we're developing. So so on the product end, we've built the entire product from scratch. It's a desktop app, it's a web app. It's we have cloud infrastructure to run all these automations to do pretty much any task you can think of. And then once those automations are built in like a custom programming language, and how so because our research and our product stuff goes together, it allows us to work on all parts of the equation. So uh, right from getting right from where the program is run to how it is made to where it is, to what are the inputs of it, what are the outputs of it, and how that program is then taken and then trained a model on that program so that it can generate more of that program later on. We have a control over this entire supply chain of the automation essentially from end to end. So it's a massive coordination problem, and we basically have now efforts established in all parts of the supply chain. So we can tweak any part of the chain to achieve anything. For instance, tomorrow I figured that okay, I need to make it really easy to make a Google search scraper, right? So I wanted to make it, if someone say types in okay, search Google for this and scrape it into random.csv, right? I can tweak things along our entire supply chain to make it very easy to generate more data, then train models of the data, and then make it very easy to just have someone say that in English, and then you have a program generate the task to do it. Yeah, that's around it. So we're going to launch in the next few weeks.
I'm really looking forward to your launch. Awesome. So,
Yeah.
my next question is that how did you meet your co-founders and how did you start building your initial team? And the second part to this question is how is your company good and why should potential candidates join your company? What about the company culture?
Okay. So I basically in my college at BITS basically founded this team called Hyperloop India, which essentially, so I mean, one thing common for me and my co-founder Shubham is essentially we like really love hard engineering problems, right? Which when you search on Google on how to do them, there's no answers. That really gets us excited. And so we started with the Hyperloop problem, which is okay, how do you shrink a plane and put it into a vacuum tube and then have supersonic speeds at the level of ground to transport humans and cargo, just like you transport data packets over the internet, right? So that was the mission of the Hyperloop, and we sort of built this team in India. We built a humongous levitating pod, took it to LA to SpaceX's competition, and that was like our first like brush with taking something from right from scratch, and then taking it to like building it like in 3 months. So that was where I met my co-founder. Oh yeah, I mean, yeah, team culture, etc. So I mean, we essentially, so just like during the Hyperloop days, we have the mission-driven culture, uh, optimized for the long term. Um, I mean, you have to be slightly nutty to be working on this, to be honest. I mean, one of the unique things uh, that we as a team sort of think about is that essentially we are the people who are working on making this making ourselves redundant. Right? So if you can essentially automate anything, you are also aiming at automating yourself, right? So it's a philosophy of subtraction. So essentially, uh, we try to automate almost everything that we do in order to make ourselves even more redundant over the process. So we use our tool to make ourselves redundant.
Amazing, Sibesh, amazing. Right. So my last question is, every startup founder and every person working in a startup has this moment of this real moment where they feel that they're building something very, very cool. So can you tell us about your moment?
So there's a lot of debates around atoms versus bits. And as someone who's actually built with atoms before, so we built like levitating stuff before. I think like software has a different kind of leverage that just bits don't have, right? So like just reduce it to what is actually happening. You have a bunch of zeros and ones, which if you arrange in a particular way, you can get food delivered in 10 minutes. You can change real estate housing prices via something like Airbnb. You can have people meet each other and marry. You can have like uh, things delivered across the world in an hour, a day. And so software is this like humongous leverage on the real world, right? Just the right programs arranged in the right way can sort of completely move things uh, um, across in the real world. And so uh, and so making machines which can make their own software or program themselves, sort of the ultimate leverage on the real world. And it's sort of like modern day alchemy. Alchemy, you had people trying to mix different elements and trying to make gold from it. So making machines which can program themselves to do any task. It's sort of like a program which creates all other programs, right? So it's sort of like alchemy, and that's sort of the most fascinating part of what we're building. Yeah,
That's awesome, Sibesh. And thanks a lot for coming here today. It was really, really nice talking to you.
sure,
Awesome, Sibesh.
sure,
See you
sure.
soon. Bye
Thanks.
bye.